Okay, so Abdul, in your batch, we have already started the determinants. So, how many topics you have completed in the determinants? We have done the basics. We have discussed about the determinants of a square matrix of order 2, or shall I revise? Shall we revise it from the scratch? Abdul?
Yes, sir.
Yeah. How many topics you have already completed in the determinants? Abdul, shall we start from the beginning? Okay, you have completed this till cofactor. Okay, so please give me a minute because I need to check for Z. Okay, just give me a minute. Okay, Abdul, then we will start from the minor and cofactor, okay? We have done this logarithmic formulas of log. Abdul, we have completed the formulas of log. No, not possible because cofactor can be done only after that. So, okay, I will check. Z, my voice is audible?
Yes.
Okay, so Z, in your batch also, matrices has been done. Okay, and same and the same case is with Abdul. He has switched from the previous batch. So we will start from the determinant so that you both of yours time will not get wasted. Okay, so Z, we have started determinants in your batch, or
Yes, sir.
okay. So can you tell me which was the last topic you have done in the determinants?
So I think triangle, area of triangle.
Okay. So we have done the area of triangle.
Yes.
Okay. And these questions, can you check? Do you have completed these questions?
So I don't have this question.
You don't have. Okay, Abdur has completed this. Then just give me a minute. Okay, because these are some important questions. You have completed this Z,
Yes, yes. This one.
and then this one.
Yes, sir.
Okay, great. Then please try this question.
Okay, sir.
Okay, and Abdur, will you please again try to solve this question? There's a very good question. Okay, after that we will start minor and cofactor. Both of you, please let me know if you will face any difficulty in this question. Okay, and one more thing, this is a square. Okay, so you can write this 2 over here. Ziyad and Abdur, any problem in this question? Sorry, Ziyad. Any doubt in this?
No, sir.
Okay, okay, good. Okay, Abdur, very good.
So if it's coming 1 upon 16, x1, x2, x3, y1, y2, y3, 2, 2, 2, and the square of matrix equal to 3 upon 16, a to the power 4. Then can we
Uh,
cancel 1 upon 16 and 1 upon 16 from both
yes,
sides?
yes, that. Please
Okay, sir.
cancel it.
Okay, sir. Then it's coming.
Okay, okay, very good. So this question is from your NCRT exemplars. Okay, next one. Next topic is minor. Okay, minor of an element aij of a determinant is a determinant obtained by deleting its ith row and jth column in which this element lies. This is a very simple topic. So we will take example. For example, if we have this determinant, this is a11, a12, a13. This is a21, a22, a23. Okay, and this is a31, a32, a33. Or before that, we will take a one more simple example. A11, A12, A13, sorry, A21, okay, A22. Suppose we have this determinant. First of all, minor is denoted by M. And now if we need to find the minor of this element, then we will write M11, okay? So we find minor of a element. In this determinant, we have 4 elements. So we will find the minor of these 4 elements. Okay, just give me a minute. This is A21. So we need to find the minor of this, minor of this, minor of this, minor of this one. So we need M11, we need M12, we need M21, we need M22. Okay. So how we find out the minor? We need to find the minor of first element. So we will remove this row and this column to which this element belong. A11 belong to the first row. This belong to first column. So we will remove this row and this column. Now the remaining element is A22. So M11 will be equal to A22. Okay. This one. Zed, can you tell me what is M12?
Sir, A21.
A21, very good. Then M21 is what?
It is 1, 2.
A12, very good. Abdur, can you tell me what is M22?
A11.
A11, very good. Okay, so for a determinant of order 2, we can easily find the minor like this. Now we will check for this one of order 3. Then suppose if we need to find the minor of first element, then what we will do, we will remove this row and this column to which this element belong. Now the remaining is, we will remove this one. Now the remaining is A22, A23, A32, A33. Okay, so we get these elements. Now we need to solve it. You know how to solve a determinant. Just multiply these two and minus multiply these two. This is clear, Zad and
Yes,
Abdul?
sir.
Okay. Okay. Now, so the same thing is written in the definition that minor of an element of a determinant is the determinant obtained by deleting its ith row and jth column in which this element lies. Same thing, minor is denoted by Mij. Next, one more thing. If we will check the determinant of order 2, A11, A12, A21, A22, okay. If we will find the minor, or we will understand this with this example, A11, A12, A13, A21, A22, A23, okay, A31, A32, A33. So this is a determinant which have the order 3. Now, if you are finding the minor, then minor is what? A22, A32, A23, A33. Okay, this is the minor. Now, if you will see here, the order is 3. And if you will check this, then this have the order 2. So that's mean whenever we are finding the minor, then the order of the determinant will reduce by 1. This clear, Zada and Abdul?
Yes.
One more thing, we can find the minor of this determinant, but we can't find a minor of a determinant which have the order 1. So that means we can find a minor if the order of the determinant is greater than or equal to 2. Okay, clear, Abdur and Zed? Oh, okay, okay, very good. So please note down this, confirm me, then we will start the question on the basis of this. Abdur, you have already completed this, so there's no need to again note down this. Okay,
Certain.
done. Okay, very good. Abdur, your question is minor of element 1 cannot be, no, I'm not saying this. I'm saying if a determinant have the order 1, for example, this one. Now we can't find the minor of this. Okay, so we can find a minor of an element of a determinant if that have the order greater than equal to 2. Okay, Abdur?
Yes.
Okay, I guess you are asking something else. Element 1 means you are trying to say that if there is only a
Yes,
single
sir.
element in the data.
Yes, sir.
Okay, yes, you are correct. Okay, so find the minor of element 6. This is the element. Zad and Abdul, will you please find the minor of this element 6?
So it's 14 minus 8 minus 6. Oh, sorry.
This is what 8 minus 14, that is minus 6. Okay, final answer is minus 6. We will remove this row and this column. So 8 minus 14 is minus 6. Very good, that is correct. Okay, so next we will start with the cofactor. Zed, the last topic is clear, minor?
Yes, sir.
Okay, now cofactor. Cofactor is related with the minor. Okay, the first thing is cofactor is denoted by Aij. Minor is denoted by Mij. Cofactor is denoted by Aij. It is defined as Aij is equal to minus 1 I plus j into Mij, where Mij is a minor. So that means what? How can we find the cofactor? We will multiply the minor with minus 1 to the power I plus j. Okay.
Okay.
So we will take example. For example, we have this one. A11, A12, A13, sorry, A21 and A22. We have these elements. First of all, we'll find the minor. M11 is equal to A22. M12 is equal to A21. M21 is equal to A12. And M22 is equal to A11. So we get these elements. Okay. Next, we need the cofactor. So this is equal to what? Minus 1 to the power 1 plus 1 into M11. Okay. If we need to find the cofactor, we will multiply the minor with this minus 1 to the power this one, these numbers. So here we will get equal. Next, we need A12. So this would be equal to minus 1 to the power 1 plus 2 into M12, which will give us minus M12. We will put the value M11 was A22. So this is minus
Okay, sir. Like first row will have plus sign, second row will have minus, then third row will have plus sign again, like that.
no, that complete row do not have the same
Okay.
elements as per these numbers. If the sum of these two numbers are even, then this will remain positive. If the sum of the numbers is odd, then it will become negative.
Okay.
Okay, so please note down this definition, then we will try a question on the basis of this.
Certain.
Okay, very good. Now find the minor and cofactor of all the elements of this determinant. Please try this.
So minor is 11 and cofactor, I think it will be 1, 1 plus, sorry, minus plus 2, then 4 and -3.
Okay, let me check. M11 is 3, M12 is 4, M21, 21 is -2, and M22 is, sorry, is equal to 1. Next we need A11. So this is 3, A12 -4, A21 plus 2, A22 is equal to 1. You're getting the same answer, Abdul?
Yes.
Okay, Zed. Abdul, that's correct. You're getting the same one. Abdul, you are getting the same answer. Okay, great. Okay, next one. Okay, then we have a very important property, or we can say a note. This is the sign of determinant. Okay, determinant is equal to sum of the product of elements of any row with their corresponding cofactor. So what does that mean? Suppose we have this determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. Now, if we are multiplying the element of first row with the cofactor of the first row, A13, A13. Okay. If we are multiplying the elements of the first row with its corresponding cofactor, it's mean we are multiplying the A11 with the cofactor A11, A12 with A12, A13 with A13, then this will be equal to the determinant. Okay, this will be equal to the determinant. So if you will solve a determinant or you will multiply this one, then the answer will remain the same. Okay, similarly, if you will take any other row, for example, second row, and you multiply it with the cofactor of the, with its own corresponding cofactor, then you will get the value of the determinant. Same with the third row, same with the first column, second column, and the third column.
Okay.
Why this happened, we will check this one. Okay, A11 we already know. We will check this. A11 we know. What is it? Now to find the value of cofactor, what we will do, we will multiply this -1, 1 plus 1. And how we find A11? A22, A23, A32, and A33. Now for the second one, A12. Okay, for this cofactor, we will multiply this -1, 1 plus 2. And then A21, A31, A23, and A33. Okay, next plus A13. Okay, and this -1 to the power 1 plus 3. Next one, A21, A22, A31, A32. So what are these values? We have put the value of the cofactor. But if we will check the formula of determinant, then while finding the determinant, we do the same thing. We select any of the row or the column. We take A11 and we do the calculation in the same way. So that means if we are multiplying this one or we are finding the value of the determinant, then both the things are same. This clear, Abdur and Zaid?
Yes, sir.
Okay, okay, Zaid. Oh, sorry. Okay, Abdur. Okay, okay. So that's why if you will take any row and multiply and add the corresponding cofactor, then you will get the value of the determinant. This is the first. This is the first one. Now the second note. Second note is what if elements of a row or column are multiplied with a cofactor of any other row or column, then their sum is 0. What does this mean? Suppose we have this determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. If we have this determinant, now suppose we have taken the element of first row, but we multiply this with the cofactor of the second row. Okay, and then we will add it, then the answer will be 0. So if you will take the elements of any row and take the cofactor of other row, okay, but the sequence should be same. If this is A11, then please take A21. A12, please take A22. So if you will take elements of any other row and you multiply with the cofactor of any other row or column, then their sum will be 0. Okay, this clear? Is that?
Yes, sir.
Okay, Abdur, this clear? Abdur, this clear? Okay, great. So please note down this, confirm me, then we will try a question on the basis of this one.
Sir,
Okay, Zed, that's great. Abdur, you have already done this. Okay, so there's no need to note down this again. Okay, so next is, okay, the question is, please find the minor and cofactor of the third row, row 3. Okay, please find the cofactor of the row 3 and then verify this. Please complete this. There's no need to find the cofactor of all. Please find the cofactor, minor and cofactor of row 3 only and verify this. Okay.
so minor is 12, 38, and 18.
Okay, Zed, you get the minor?
Yes, sir.
Okay, then please verify this A11, A31. Okay, please check this. Are you getting 0? Abdur and Zed, please let me know once it is completed. Okay.
Okay, so 0 is 1.
Is that very good? Abdur, this completed. Shall we start next? Okay, Abdur, good. Okay, so Abdur, you have completed the adjoint also? Okay. Okay, so what is the adjoint? Adjoint of a square matrix is the transpose of the matrix, this one, where Aij is the cofactor of the element Aij. Adjoint of the matrix is denoted by adjoint of A. So we will take example and try to understand this. Suppose we have this matrix. Okay, this is A11, this is A12, this is A1, sorry, A21, this is A22. We have this matrix. So first of all, adjoint is denoted by this one, adjoint of A. Okay, now, first of all, we need to find the cofactor. So you already know how can we find the cofactor. Okay, so next is A21 and this is A22. So by this we can find the cofactor. Now what you need to do, adjoint is equal to, it is the trans. Now please find the cofactor and write the cofactor in this matrix in the same order. Okay, in the same sequence, A21 and A22. So adjoint of A is equal to this one. Okay. Now adjoint of A is equal to, we will find the transpose of this matrix. So how we need to find the adjoint? First of all, you will find the cofactor. You will arrange the cofactor in the matrix in the same sequence. At the place of A11, you will write this, A12 like this. Then you will find the transpose of this matrix. So you will get what? Adjoint of A is equal to, this first row becomes first column. So A11, A12. Second row becomes second column, A21 and A22. Okay, this clear? Is that?
Okay, sir.
Okay, very good. So please note down this and confirm me. Okay, then we will start a question on the basis of this. The same thing is written over here. Here we have taken an example of this 3 by 3 matrix. Please let me know once it is complete.
So done.
Okay, that's very good. So Abdur, you have already noted this. Okay. Now, please, Abdur and Zed, try this question. Find the adjoint of A. Please try this.
Sir, adjoint is 2 minus 1, 3, 4.
2 minus 1, or is it 4 minus 3 minus 1 and 2? I guess you forgot to
So
take the transpose.
should we also change the diagonal?
You need to take the transpose of the matrix. Okay. So for example, for this one, you have find out the cofactor. So that is 4. And for this one, minus 1. And then for this one, minus 3. For this one, you will get 2. Then you need to take the transpose of this. Okay. So transpose is what? 4 minus 1 minus 3 and 2. This clears that?
Yes.
Okay. Now, for 2 by 2 matrix, we have a very shortcut method, but please don't use this in your exam. Okay. Okay. If suppose we have this matrix, then adjoint can be found out by interchanging these two. For a 2 by 2 matrix, directly you can find a adjoint by changing these two, interchange these two. Okay, and put a negative sign over here. If we will check this one, directly we can write like this, shift 4 here, shift this 2 to this side, and put a negative sign, minus 3 and minus 1. So this is a shortcut method for order 2 by 2. But please don't use this in your exam. Okay. Okay, Zat, this clear?
Okay.
Okay, then please note down this remark also and confirm me, then we will start the next topic. Okay, Abdur, adjoint of A, how we need to find? First of all, we will find the cofactor. Okay, so for these, we will find first of all cofactor. So A11 is equal to what? 4. A12 is equal to what? Minus 1. A21 is equal to what? Minus 3. And A22 is equal to what? 2. So we have find out this cofactor. Now adjoint of A will be equal to, okay, Zat, good. Adjoint of A will be equal to, write the cofactor in the same sequence, A11, A12, A21, A22. Okay, and then find the transpose of this. So what you will get, 4 minus 1 minus 3, 2, and take the transpose of this one. So what you will get here, 4 minus 1 minus 3 and 2. This clear, Abdur? Abdur, this clear? Okay, very good. So Abdur, we are going to start next, okay? Now, we have some theorems. So first theorem is, if A is any square matrix of order n, then A into adjoint of A is equal to adjoint of A into A is equal to determinant into I. Okay, where I is the identity matrix of order n. This is the first theorem, that A into adjoint of A or adjoint of A into A is equal to determinant of I, where I is the identity matrix of order n. We will do the proof of this. Okay. Let A is equal to, we have this matrix A11, A12, A13, A21, A22, A23. Then we have A31, A32, A33. Okay, so we have these matrices. Now, we'll find the adjoint of this. So we will write just the cofactor. So here, if you will find the adjoint of this, then you will get what? A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so this is the adjoint of A. Now, A into adjoint of A. Multiply A with the adjoint of A. So this will give you what? This is A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. Now multiply this with the adjoint. So we have already find out the adjoint, which is A11, A21, A31, A12, A22, and A32. Then we have A13, A23, and then we have A33. Okay. Now, if you will multiply this, you already know that first row will get multiplied with the first column. Now, if you will check this, A11 will multiply with cofactor A11 plus A12 will get multiplied with A12. A13 will get multiplied with A13, and then we will add all these. Set, we have noted to note just 10 minutes back. So can you tell me what happened if you will multiply the elements with a cofactor and add them? What you will get?
So we'll get adjoint.
Determinant.
Sorry, determinant.
Okay. We have just done two notes. Just give me a minute. Yes, these two. Okay, so the first note is sum of the product of element with its corresponding cofactor will give you the determinant. And if you will add the element, if you will multiply the element with the cofactor of any other row or column, then the sum will give us 0. Okay, so now, okay. Now, Zed, can you tell me if you will multiply first row with second column, what will be the result?
It will be A11
Into
cross
A21
into A21, then addition A to A12 cross A22, then
and A13
A13 plus A2.
or A23. So what will be the final answer? If you will add these three, then what will be the answer?
Uh,
Please check the note too. The first note was if you are multiplying any element with its corresponding cofactor, then you will get the determinant. But if you will multiply any row or column with a cofactor of any other row or column, then the answer will be
a determinant AI.
no, that will be 0.
Uh,
Please check. This is first row element, and this is second row cofactor. So that will be 0. Okay.
okay.
Okay. Abdur, we have completed this theorem in your batch. You have done this theorem, Abdur? Abdur, yes or no? Abdur, you have completed this theorem? No. Okay, okay. Then Abdur, please check here. A into adjoint of A or adjoint of A into A is equal to determinant into I. So we are proving this theorem. What we have done, we have taken this matrix 3 by 3. We have find the adjoint of this. Okay. So we know that what is the adjoint? It is the transpose of the matrix which are having the cofactor. So this is the adjoint of A. Now we are just multiplying these two. We have taken first row and we are multiplying this with the first column. So first row element will be multiplied with these are the cofactor of the first row. That's why we will get the determinant. First row, these element will give you 0. Similarly, first row, these are the cofactor of the third row. So you will get a 0. Abdur, this is clear up to now. Up to this step, this is clear. Okay, great. So Abdul, can you tell me the second one? If you will take a second row and we will multiply with the first column, then what will be the answer? Second row and first column, Abdul, what will be the answer?
So can I?
Yes, yes, sir.
So 0, A,
0,
again,
determinant of A,
again 0.
0. Very good. Abdul, please check here. These are the elements of the second row. Okay, and these are the cofactor of the first row. A11, 12, 13 are the cofactor of the first row, and these are the elements of the second row. So as per the second node, this will give us 0. This clear, Abdul? Abdul, this is clear. Okay. Now these are the element of second row, and these are the cofactor of the second row. So this will give us determinant as per the first node. Similarly, these are the element of the second row, and these are the cofactor of the third row. So this will give us 0. Okay. So Abdul, please tell me the last one. If you will take the element of the last row and you will multiply with the cofactor of first row, then what will be the result, Abdul?
0, 0, determinant of A.
Very, very good. 0, 0 and determinant of A. Now you know that in a matrix we can take out anything common, but from all the elements. So if you will check in the first row, we have the determinant. From 0 you can take anything common. Okay, in the second row we have the determinant. In the third row we have the determinant over here. So from this complete matrix we can take determinant common. So we will get what? 1 0 0 0 1 0 0 0 1. Okay, and we know that this is what? This is determinant of A into I. So this is the proof of this theorem. Okay, please note down this, confirm me, then we will start the next theorem. Or if anyone have a doubt, then please let me know.
So done.
Done? Okay, good. Abdur, this done? Abdur, please confirm me. Oh, okay, okay, okay. Take your time. Sir, shall we start next?
Okay. Sir.
Okay. Okay, then we are starting the next topic. Now, theorem 2. If A and B are non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. So first thing, Abdul, what is mean by non-singular matrices? Abdul, what is mean by non-singular matrices? I guess this we have done in the first class of determinant. Okay, no issue. Please revise it. Zed, what is mean by non-singular matrix?
So those matrices which are equal to 2 or are greater than 2.
No, 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 no. Non-singular.
Non-singular. Which are not equal to like a single unit matrix.
No. Suppose A is a non-singular matrix, so that means determinant of A should not be equal to 0. Okay.
Okay.
Non-singular matrices are those of which determinant is not equal to 0. What is a singular matrix? Whose determinant is equal to 0. Okay. So in this one, it is given A and B are non-singular matrix. So that means determinant of A is not equal to 0. Determinant of B is not equal to 0. This is given. Now they are saying that AB and BA are also non-singular matrices of the same order. So that means if you multiply AB, then determinant of this is not equal to 0. If you will multiply B and find the determinant, then this is also not equal to 0. Okay, so this is the theorem. If you have two matrices and they are non-singular, and if you will multiply them, then the the result will also be non-singular. Okay, so Abdur and Zaid, this theorem is clear? Theorem 2?
Yes.
Okay, Abdur, this clear? Abdur, this clear? Okay, great. So please note down this and confirm, then we will start the next theorem. Okay, Zaid and Abdur, shall we start next?
Yes.
Okay, Abdur, this done? Okay, great. Now next one. Next property is the determinant of the product of matrices is equal to product of the respective determinant. That is this one. Okay. Now suppose if we have two matrices, we have multiplied them and then we are finding the determinant. We have two matrices, we have multiplied them and then we are finding the determinant. Then this will be equal to if you will find the product, sorry, if you will find the determinant of these matrices separately and we will multiply them. Okay, so if you will multiply two matrices, find the determinant, that will be equal to find the determinant of A, find the determinant of B, and then multiply these two. This clear? Abdur
Okay,
and
sir.
Sir? Okay. Abdur, this clear? Abdur? Okay, great. So please note down this, confirm me, then we will start the next year.
So finished.
Okay, good. Abdur, this done? Abdur, shall we start next? Okay, great. Okay, please note down this. If A and B are square matrices of the same order. Okay. Now, next property. If A is non-singular matrix of order n, then adjoint of A will be, sorry, then the determinant of adjoint of A is equal to determinant A and minus 1. We will do the proof of this. Okay. Proof. Let A is equal to this matrix for the 3. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so we have this matrix. Now, you already know that what is the property A into adjoint of A. Abdul, can you tell me what is the property? This is equal to what? Abdul, can you tell me this property? Very good. This is equal to determinant into I. Okay, now we have this A into adjoint of A. This equal to determinant of A. We will write the identity matrix. Okay, if the matrix is of order 3, then identity should also be of order 3. Now, A into adjoint of A. This is equal to, okay. So please multiply this determinant with this matrix. So all the elements will get multiplied with determinant. 0 determinant A, 0 and 0, 0 determinant. This is the difference between the determinant and the matrix. If you have any number, or if you are multiplying a matrix with any scalar, with any number, then all the elements will get multiplied with that. But in case of determinant, only a particular row or column get multiplied with that. Okay. Now we have this. Now we will take a determinant on both the sides. Now what will happen? If we will take determinant, then this will become A into adjoint of A. Okay, determinant. And this is equal to, we have this determinant of A, 0, 0, 0 determinant of A is 0, and 0, 0 determinant of A. Okay. Now A into adjoint of A is what? We have this determinant of A, then adjoint of A determinant, and this is equal to. Now this is a determinant. That's why we will take determinant common from the first, second, and the third row. So from the first row, we can take determinant A common. From the second row, we can take determinant A common. From the third row, we can take determinant A common. So inside this determinant, we will get 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Up to this step, it is clear, Abdur and Zed?
Yes.
Okay. Abdur, this clear? Okay, good, Abdur. So now what we will do, we will cancel this determinant. Now, Abdur, can you tell me what is the value of this determinant? Value of this determinant is 1. Okay, because this is an identity matrix and determinant of identity is always 1. Now here we have determinant square. Okay, here we get a square and this is 1. So adjoint of a determinant is equal to determinant square. Now we can write this like this: adjoint of A is equal to determinant of A. In place of 2, we can write 3 minus 1. Now what is the 3? 3 is the order of the matrix. Okay. Now if you will compare this with the theorem, then theorem states that adjoint of A is equal to determinant of A n minus 1, where n is the order of the matrix. So same thing we got here. Here we get a 2. 2 means 3 minus 1. So if you are finding the determinant of adjoint, so that will be equal to determinant to the power n minus 1, where n will be the order of the matrix. Okay. So Zad and Abdur, this theorem is clear?
Yes.
Good. Abdur, this clear? Abdur, this theorem. Okay, great. So please note down this theorem. Then we will start the next one. Please note down this theorem and note down the proof.
So finished.
Okay, Zad, very good. Abdur, please confirm once it is done so that we can start the next. Okay, done. Great. Now next, there's a very, very important topic, inverse of a matrix. Okay, we can expect a question, one question from this topic, inverse of a matrix. Now, what's the inverse of a matrix? A square matrix of order n is in. Before that, what is invertible? First thing, if inverse of a matrix exists, then we will say it is invertible. Okay, I will repeat again. If inverse of a matrix exists, then we will say that it is invertible. Okay, if inverse of a matrix exists, then we will say that it is invertible. Now, suppose, please leave this definition, check here. Suppose we have a square matrix A here. We have a square matrix A. If we will multiply this A with another matrix B, and you are getting an identity matrix, then B is called the inverse of A. Then B is called the inverse of A. Suppose we have a number 2, we will multiply this with 1 by 2. and we get a 1. So 1 by 2 is called the inverse of 2. Similarly, if we have a matrix A, we are multiplying this with B and we are getting identity, then B is called the inverse of A. Okay, A inverse is denoted by this one. A inverse is equal to this. So A inverse is equal to B. Zad and Abdur. This is clear.
Yes.
Abdur, this is clear. Abdur, do I need to repeat one more time or this is clear? Okay, very good. Okay, so if we have a matrix A and we will multiply this with matrix B and we are getting identity, and the same thing will happen if you will multiply in this way. A should be a square matrix. Okay, and you're getting identity, then you will say that B is the inverse of A, and inverse of A is denoted by this sign, A inverse. So here we are saying that B is the inverse of A. So please note down this, confirm me, then we will check the next topic or do some questions on the basis of this one. Please confirm me once it is done.
So finished.
Okay, so that's very good. Abdur? Abdur, please let me know once it is done. Okay, great. Now, next theorem. A square matrix is invertible. That means inverse of a matrix A exists if and only if A is non-singular. Okay. Now, Zed, what is non-singular? What is a non-singular matrix?
If it is a, if the matrix is equal to 0.
Very good. If the determinant of the matrix is not equal to 0, then we will say that it is non-singular. So if the matrix is non-singular, then only its inverse will exist. Okay, how can we check that a inverse of a matrix exists or not? We will find the determinant. If it is non-singular, then we will say that it is invertible. Its inverse exists. Okay, if it is a singular, then its inverse do not exist. So please remember, if you get a question in 1 mark, that please check the matrix is invertible or not. The inverse of a matrix exists or not. Then please find the determinant. If that is non-singular, then inverse of a matrix exists. There is no need to find the inverse. In question, in 1 mark question, they will just ask you, please check that the inverse of the matrix exists or not. Okay, so just find the determinant and check it is non-singular or not. Okay, we will do the proof of this. A into adjoint of A, this we have already discussed, that this is equal to determinant of A into I. Okay, now shift this determinant to the left side, so we will get A into 1 by determinant of A adjoint of A, and this is equal to I. If we will check the definition of the inverse, if A is a square matrix, we will multiply this with B and we are getting identity, then we will say that B is the inverse of A. Okay, apply the same concept here. Here we have a matrix A, we are multiplying this with the matrix this, and we are getting identity matrix. Then can we say that A inverse is equal to this one, 1 by determinant of A adjoint of A? This is clear, Zad and Abdur?
Yes.
Abdur, this is clear? Okay. Now please check, in the denominator we have the determinant. In the denominator we have the determinant. So always remember, in mathematics you should never have a 0 in the denominator. In the denominator we have a determinant. So in mathematics, please make sure that in the denominator you do not have the 0, otherwise this will become not defined. Okay, so when this inverse will exist, when this determinant will be equal to what? When this determinant will be equal to not equal to 0. Okay, if this determinant will become 0, then this will not exist. This will become not defined. That's why if inverse to be exists, the denominator should not be equal to 0, and the denominator we have the determinant. Okay, So this is clear, Abdur and Zad, the theorem fifth.
Yes.
Okay, Zad, sorry, Abdur, this clear? Okay, good. Okay, so please note down this theorem and note down this last point. The last point is same. Okay, this theorem provides us this formula. So we will use this formula to find the inverse of a matrix. We will use this formula to find the inverse of a matrix. So if we have a matrix A, we need to find the inverse, then we will use this formula. 1 by determinant of A into adjoint of A. So you already know how can we find the adjoint. You just need to divide the adjoint with the determinant. You will get the inverse of A. Please note down this, confirm me, then we will try some questions on the basis of this one. Okay, Abdur. Zed, this is done?
Yes, sir.
Okay. Okay, then we are going to start a question on the basis of this. Okay, Abdur, if you have any doubt in this, please let me know. Okay, this is a very important formula, this one. A inverse is equal to 1 by a determinant adjoint of A. Okay, we can expect a question from this formula. Now, we need to find the inverse of this matrix. Okay, can you do this? You just need to find the adjoint, divide that with the determinant, you will get the inverse. So first of all, let A is equal to, let this is a matrix having the element 2, -1, 3, and 4. Okay, now please find the inverse of this. Please complete this and share your answer.
So should we say adjoint?
Yes, first of all, you need to
So
find the,
minus. Okay.
okay,
So
okay.
adjoint is -4, -1, 3, -2.
Why it is -4? No, adjoint should be 4.
Sorry, I changed that.
So 4, 2, 1, and -3.
Yes.
Okay, good. Now divide this with the determinant.
So determinant is coming 11.
11, very good. So please divide all the elements. Okay, divide the adjoint with determinant and share your answer. Abdur, please let me know if it is done.
So 4 by 11 minus 1 by 11, 3 by 11,
Minus 3 by 11 and 2
minus.
by 11. Okay, good. Okay, Abdur, good. Now, next question is this. If A is this, then verify that A into adjoint of A. This question is your homework, okay? My target is next Saturday, we will try to complete this chapter, okay? So there's a very simple question. You can do this in the homework. So please note down this one and note down the answer. Please complete this in the homework, okay? And try to upload your homework till next Friday. This question is in the homework. Please confirm me, okay, once it is done, Abdur Ansar.
So
Okay, good. Abdur, this done? Abdur? Okay, great. Okay, please don't miss this question, complete it. And if you will face any doubt, we can discuss this in the next class. But This is a very simple question, so I hope you will not face any issue in this. The same is with this one. Okay. So there's one property. I missed this property. Property of inverse. Property, you can say one. Like transpose, if we have two matrices and we are finding the inverse of this, two matrices are getting multiplied and we are finding the inverse of this, then this will be equal to B inverse A inverse. Okay, these two matrices will interchange their position. So this is the property. Please note down this property. And here you need to verify this. You have two matrices, you need to verify this. So this question is also homework. Okay, this is a very, very simple question. So you can do this
Certain.
on your own. Okay, Seth, good. Abdur, please note down this. Note down this property. Okay, and complete this till Friday. Abdur, please let me know once it is done. Abdur, shall we start next? Okay, good. Okay, so this is a very good question. Show that the matrix satisfies the equation. This one, using this equation, find A inverse. Okay, first of all, please show this one. Okay, what you need to do, find A square, put minus 4A plus I, you will get a null matrix. Please do question number 4. Please do the first part. Second part, I will explain this to you. Okay, please let me know once it is completed. The first part is done. Abdur and Zed.
So it's coming 0, 0, 0, -2.
No, not 0 minus 2. It should come 0. There's a null matrix. Okay, please check the
Okay.
calculation. Sir, the first part is done. Are you getting the null matrix? Abdur?
Okay. Okay.
Okay. Okay, that's good. Abdur, yes or no? You have completed the first part. Oh, okay, okay, Abdur. Take your time.
Sir, adjoint is coming 7 and
Zed, we will find the A inverse by using this equation. Okay. So whenever in the question it is written that using this equation find A inverse, okay, or they say the hence find A inverse, then we will use the data which is given in the first part. No issue of the, I will solve it. So A is equal to 2, 3, 2, 3, 1, 2. Okay. Now A square is what? It is equal to 2, 3, 1, 2, 2, 3, 1, 2. Okay. So A square is equal to, multiply this, first row, first column. So this is 4 plus 3. So 6 plus 6, 2 plus 2, 3 plus 4. So we will get this A square is equal to 7, 12, 4, and 7. Okay. Now this equation A square minus 4A plus I. So put the value 7, 4, 12, 7 minus 4A. A is what? 2, 3, 1, 2. 2, 3, 1, 2. This is 3 plus I. I is 1001. Okay. Next. So we will get what? This is 7, 12, 4, 7. Multiply this negative 8, 12, 4, 8 plus 1001. Okay. Now 7 minus 8 is minus 1, minus 1 is 0. 12 minus 12 is 0. 4 minus 4 is 0. 7 minus 8 is minus 1. This is equal to null matrix. Abdur, this is clear? Okay, great. Okay, Abdur, please note down this and confirm. Then we will check that how can we find the value of A inverse. Okay. Abdul, you have noted this. Shall we start the next part? Abdul, shall we start the next part? This done? Abdul, yes or no? Okay, okay, great. Now, so whenever in the question it is given that using this equation find A inverse or hence find the value of A inverse, then in such cases, please don't solve the question directly. Otherwise, you will not get the marks for the second part. Okay. We have this equation. We need to use this equation to find the value of A inverse. Now, what we will do, this A square can be written as A into A minus 4A plus I is equal to null matrix. Okay. Now, what we will do, let this be 1. We will multiply 1 by A inverse. Okay, so we will get what? Okay, always remember, if you are multiplying an equation by a matrix, then you have two options. You can multiply from this side or from this side. It's your choice from which side you need to multiply, but always follow this sequence. Okay, so it's our wish. We are multiplying from this side. So A inverse will get multiplied from this side. So this will become A inverse. Then we have A into A minus 4 is a constant, so that's not an issue. We will multiply from this. So first of all, A inverse will come, then A plus, we will multiply A inverse with I. So we will get this into I is equal to null matrix. Okay, sorry. Just give me a minute. Okay, this is equal to A inverse into null matrix. Okay, yes, we can shift all the terms to the right side. Okay, observe, but we need A inverse. So that's why we need to multiply the complete equation with A inverse. Now A inverse into A. This is what? Abdur, can you tell me what is the value of A inverse into A? Abdur, can you tell me what's the value of A inverse into A? I, very, very good. Okay, is that this clear? We have already done.
Yes.
Then I into A minus. Again, A inverse into A is I plus. Always remember, if you are multiplying any matrix with identity, you will get the same matrix. So A inverse into I is A inverse is equal to null matrix. Now, I into A is A minus 4I plus A inverse is equal to null matrix. Okay. Now we need the value of A inverse, so we will shift all the terms to the right side. So A inverse is equal to null matrix. Shift this. This become minus A, and this become plus 4A. Okay. Now put the value and find the value of A inverse. So this is what is 0, 0. This is a null matrix. Minus A. Minus A means 2, 3, 1, 2. Plus 4I. Plus 4 into I. So this is 1, 0, 0, 1. Solve it and you will get A inverse is equal to, solve this. So minus 2 plus, okay, you will multiply this becomes 4. So minus 2 plus 4 is 2. Then minus 3 and 0 is minus 3. Then minus 1 and 0 is minus 1. Then minus 2 plus 4 is 2. So you get this value. Okay, this clear? Abdur and Zat?
So can you explain again?
Yes, the complete or a particular step, Abdur?
Sir, sir, after multiplication.
After multiplication. Okay, okay, then I will rub this part. Okay, so Abdur, A inverse into A will be what? Identity. Okay, then we have this A, then minus A inverse into A is again I. So 4 we have, then I plus A inverse into I is A inverse, and this is equal to null matrix. A inverse into null matrix is null matrix. Abdur, this is clear up to this step.
Yes, sir.
Okay, then what we need to do, we need the value of A inverse. So we will shift all the terms to the right side and keep A inverse to the left. So A inverse is equal to, we already have the null matrix here. This minus 4i, this on the right side, when we will shift it, this becomes 4i. And this is IA. Okay, if you will shift this to the right side. Okay, first of all, Abdur, what is I into A?
I.
No, not I, A. Always remember, if you're multiplying identity with any matrix, then we will get the same matrix. This clear? Okay, so this is actually what? This is A. So if you are shifting this A to the right side, we will get minus A. This clear, Abdur?
Yes, sir.
Okay. After this, we just need to solve this equation and we will get the value of A inverse. Okay. Now A inverse is equal to, put all the values, null matrix means 0, 0. 4i means 4 into 1, 0, 0, 1. Minus A means 2, 3, 1, 2. So here we will get A inverse is equal to, this is 0, 0, 0, 0 plus 4, 0, 0, 1. Okay, minus 2, 3, 1, 2. So here we get what? A inverse is equal to, please solve this. 4 minus 2 will give you 2. Then 0 minus 3 will give you minus 3. 0 minus 1 will give you minus 1. And 1 minus 2 will give you minus, oh sorry. Here we will get a 4. We will multiply this matrix with 4. We will get a 4. 4 minus 2 will give us 2. Okay, this clear, Abdur?
Yes.
Okay, great. Okay, so please remember, if they will say to you to solve this using the equation or hence find the value, then please use the data of the previous part. Okay, now we still have 30 minutes. Shall we continue or you are done and I will give you the homework and we'll continue the rest of the topic in the next class.
So can you give me the homework? Like,
Okay, so okay, not an issue. So what we'll do, we will do from the next class after 1 hour, we will take a 5-minute break so that we can again continue it. Is it okay? Is that?
so actually I have class tomorrow. I have like exam tomorrow.
You have another class right now?
Exam. I have exam
Okay,
tomorrow.
you have an exam. Okay,
Yeah.
okay, no issue. Okay, so please note down this and just give me a minute. I'm checking the assignments. Just give me a minute. Okay, so your homework is assignment 1 to 4. Okay, so I'm not sure how many assignments you have completed. I guess 1 and 2 you have already done. You need to complete assignment 1 to 4.
Okay. Sir.
Okay. Okay then. Thank you.
Thank
Thank
you,
you,
sir.
sir. Bye,
You're
sir.
welcome. You're welcome.